Good afternoon, dear colleagues. Welcome to our traditional research seminar at the National Bank of Ukraine, our traditional research event. And today we are very happy to host Dr. Inessa Lав, who is a professor of economics at the University of Hawaii, at Mano. And she graduated from Zaporizhsky State University, then obtained her master's degree in financial economics at the American University in Washington, D.C., and PhD degree in economics and finance from Graduate School of Business of the Columbia University. And before moving to University of Hawaii, Professor Lав worked for a long time for World Bank, where she covered research and operational issues. And today, Professor Lав will give us a seminar on the application of the panel VARs in economic research. Actually, I know that one of my colleagues uses heavily this method for investigations of economic relationships in the independent world. And I suppose that many of you may also use this quite powerful tool for your own research. And I hope that today you will get some insight how this method can be used for economic research, for different economic research. And I will probably stop here and pass the word to Professor Inessa Lав, who has definitely much more to say about the application of this method. Please.
Okay, thank you very much. It's great to be here. It's great to be back. As you all know, I'm from Ukraine, so I feel especially very good to be here and tell you about my work in the past number of years that I've studied in the different universities in America. You can ask me questions at any time. Don't wait until the end, because at the end I have a lot to present, so I may not leave very much time for questions. So if you have questions, we can start with questions. You can ask me anytime. Please don't hesitate. So this is basically what I would like to talk to today. I'm going to give a little bit of outline, basic panel data setup, a bit of econometrics. I don't know how much you know, but I'm going to start with just the panel data and some challenges in estimation of panel data with dynamic panel data models. And then I'm going to talk about panel VARs and estimation. And most of the talk, I want to talk about applications. Mostly the work that I have done, I plan to talk about 3 different projects that I have done using this method. And the 3 projects I selected to give you a good range of possible applications. And then at the end, I'm going to tell you a little bit about this data package of programs. To be honest, this is what I'm most known for, is for designing this package of programs. Now, I didn't train to become a panel VAR person. It just happened when I was studying at Columbia University, when I was a student there, maybe in 2000. And my professor hired me as a research assistant to develop this package of programs in Stata. So I did it because, you know, I was a math major before, so programming Stata was kind of easy and fun for me. So I developed this package of programs just basically for getting paid $15 an hour. That was a going rate at the time. And never thought that I'm going to become sort of an own expert on in this field. But then I published one paper, one of the very first paper that I published using this method. I'm going to talk to you about that paper today. And in that paper, I kind of made a maybe mistake or maybe not mistake. I put a footnote which said, if you want the programs, you can email me and I will give you the programs. Now, little did I know that people from all over the world are going to start emailing me and asking me for the programs. And I started keeping track of them at first, but then I'm just like, forgot about it. So a lot of people, all the PhD students from all over the world, the master students and researchers started emailing me about these programs because they just there was nothing else in Stata that was easy to use and was developed. So that's how I became an expert in this field. Okay, I never tried, but it just happens like that. So that's about history. Okay, so this is the outline. The very first paper in here This just been published last year in this data journal. So finally, after 16 years, this package of programs, now it has been redesigned by one of my students now, who is now better than I in Stata, I have to admit, after this year. So Michael Abrigo is my colleague. So we redesigned this package for new Stata. You know, my original was written in Stata 6, and now it's Stata 14. So now, finally, it was published, and it's now officially available from the Stata Journal website. So people don't have to email me anymore. They can just go on Stata Journal and get it. And the 3 applications that I'm going to talk about, those specific papers that I've published over the years. So that very first one. Right, so that's the very first paper that I published with my was my friend in PhD school, Leah. She is now in Italy, the Quarterly Review of Economics and Finance. So these are the 3 papers that I'm going to tell you about, that were all written using this package of programs. Now, any questions so far? Everyone can hear, understand me? Fine? Any questions before we begin?
In what language is this program? All right.
Stata. Yeah. Okay, Stata Journal, written in Stata. Good question. Any other questions? Okay, so like just a little bit of econometrics for you. So the really basic panel data setup. Okay, so we have I is a cross-sectional variable and T is a time variable. So we have dependent variable, independent variable, and one of the challenges in panel data is to get rid of this CI, which is fixed effect, which is time invariant, unobservable determinant of Y. Let's say, just for example, we can have banks, like Ukrainian banks. This would be I, the cross-section. I don't know how many banks you guys have in Ukraine, maybe 100, 500? I don't know. How many banks in Ukraine?
Less than 100.
Less than 100, fine. It could be 50 banks, that would be I, and we observe them, let's say, over 10 years of data. Say we could collect those data on banks. Now, we could have any dependent variable. Let's say we can look at bank performance. So we can look at bank credit or growth of credit or return on assets, anything you can imagine that you want to consider. And it will be regressed on a bunch of control variables. Well, we talked over lunch about corporate governance and the board composition, for example, which I just learned that there are some big changes in the banking sector. It became more transparent, which is always a good thing. Maybe you want to research how this change in bank governance affected the bank performance. That would be a good little research project. And you would use some model like this. Okay, so in this case, the CI is the thing is going to create some problems for us, which is called fixed effect. This would be some kind of specific bank characteristic. Like each bank will have something unique about that bank that is not measurable. Okay? That's why it's called unobservable heterogeneity. Heterogeneity means they are different from each other in some ways that we cannot really observe because we cannot measure. Okay? So that would be an example of the model like that. So if, okay, so the xt has to be uncorrelated with the error term. This is a standard assumption that we need to use ordinally least squares, which is like the simplest regression model you can imagine. Now, this is not going to work because this is unobservable, so it becomes part of the error term, and it's no longer exogenous. So different estimators have been designed that deal with this problem. So I'm going to mention some of this. This is first difference. So if you difference this equation 1 year to the next year, so you get first difference. By differencing this equation, you can remove this fixed effect. So it's gone. Then you can estimate it by all this. That's not a problem. Fixed effects is you're going to do time difference. So instead of differencing 1 year from the next year, you can just take the mean out. So if we have 10 years of data, you can average everything over 10 years, subtract that mean, and that removes the fixed effects. Okay? So those are just standard panel data methods that were designed to deal with this problem, that the fixed effects is unobservable. Okay? So, however, these methods require what's known as strict exogeneity. So the error term has to be independent of the x for all periods, past and future. This is going to be a bit of a problem when we start talking about dynamic panels, such as panel VAR. Panel VAR is just an example of a dynamic panel. Okay? So what could happen, for example, in our little model of bank performance? Let's say we took those Ukrainian banks and we took 10 years of data, and we want to see how corporate governance affect bank performance. So Y variable would be bank performance, which you could use any measure of bank performance. Maybe return on assets is a common measure used for banks, or maybe growth of assets, something like that. Okay? So what could happen is if a bank has like a really bad year, for example, so that the realization of the U is going to be pretty bad, something bad happens to the bank, it will affect future X, right? It will affect future bank composition, board composition. Okay? So this will violate the strict exogeneity assumption. So the error term in 1 year is going to affect future realizations of X. Okay? So that means we will violate strict exogeneity. So that will create a bit of a problem in estimation. We no longer will be able to do fixed effects or first differences. Okay. So this is just some other examples of different models. Different examples of application. For example, when I worked at the World Bank, a very important question that many researchers were asking themselves is, does foreign aid helps countries to grow, right? Is foreign aid good for the country, or is it actually bad for the country? Or maybe it just does nothing. Okay, so by the way, my opinion is this question has not been settled in the literature. A lot of people say foreign aid is plain bad and evil because it creates corruption, right? And corruption is bad for economy. Let's say Bill Easterly is one of the opponents of foreign aid. He thinks that we should not give countries foreign aid. And on the other side, I just forgot the name. But I will remember, a lot of people say, no, we need to give foreign aid, and in fact, we need to give more foreign aid because we haven't been giving enough, and that's why we didn't see the effect. I don't know how to stop that. Okay, so this is just some examples. I'm not going to go through all of them. All of these examples will violate the strict exogeneity because in the foreign aid example, if a country has a bad year, they're going to get more foreign aid, hopefully, right? So then you're going to violate strict exogeneity. So the next year, growth may be affected. Okay. By the way, you can ask questions anytime, okay? If you need to clarify something. Okay, so this is a special case. This is called dynamic panel. What is different here is we have a lag-dependent variable. Now we're getting closer to panel VAR, okay? So because our panel VAR is going to look similar to this. So when we have a lag-dependent variable, so you see here is yt minus 1, it's the same thing as here, right? So any model that implies slow adjustment will have this feature. It will have lag-dependent variable. So now instead of the x, we have lagged y. Obviously, this will violate our strict exogeneity assumption because now current realization of the shock is going to be correlated to the next year y. Okay? So none of the standard panel methods is going to be useful in this situation. Okay? So if none of this is going to work. First difference no longer works, fixed effects no longer works, random effects doesn't work. So what to do with this kind of model? Well, you have to do a little bit more complicated things. First thing, you have to difference it out anyway. So now you created first model and first differences. So this symbol means each of this is a difference. Okay? So, but even if we difference it, now the difference u is correlated with the difference y because it has the same time period. Each difference contains the same time period. Okay? High ut minus 1 will result in high yt minus 1. Okay, you see, it has the same t minus 1 in both differences here. Okay? So even if we differenced it out, we cannot use OLS anymore, but we can use instrumental variables. And that's the first approach has been developed to deal with this kind of model is Anderson and Xiao in '82. So what they did is first you difference it, then you use instrumental variables. Okay, so now we can use yt minus 2, notice the time here, as an instrument for yt minus 1 for the change. Okay? Because now the t minus 2 is not going to be correlated with the error term. You see, this is far enough back time. The t minus 2 is not correlated with any of this. Okay? How many people have seen this before? Can you just like raise your hand so I know what's the, how many people are kind of following this so far? Okay, good, thank you. So what would be the problem with doing this model? Okay. The main problem here is this variable is really not a good predictor. T minus 1 is not a good predictor of the difference. So technically it's a correct model, but it's a weak instrument. Sometimes weak instrument is not going to be very reliable. So there have been some other developments in this literature. Arellano Bond 91, they created difference GMM model, and Blundell and Bond 98 is a system GMM model. Okay, so there is another option. Instead of first difference, we can do what's known a forward difference or forward orthogonal deviation. That's an alternative transformation. If you study the econometrics, the standard fixed effect is taking the mean over all time periods, subtracting that. Well, we already discussed that that's not okay because the strict exogeneity is violated. This method only will subtract the future mean. And then it's going to use the lagged values as instruments. So that becomes technically correct method. So this method is in a way similar to first differences, but it has a bit of a better properties. Okay, this is more technical what it looks like. Each variable we subtract the mean of all the future periods. So if you have 10 years of data for those Ukrainian banks that we kind of use as an example, each observation you're going to transform it to difference out future years. And once you've done it, then the past can be used as an instrument. And this one we're going to equalize the variance because every different year is going to use different number of variable future years. Okay, so this transformation has some better properties than first differences. I'm not going to go through all of this in such detail. By the way, if any of you want a copy of this presentation, you can either contact me or maybe Sergey. I don't know if you're willing to.
Usually we upload it on this website.
Okay, perfect. It's going to be uploaded to the website so you can have all of this. Okay. So both transformations are going to lose 1 year of data. The first difference, you're going to lose the first year, and the future orthogonal difference, you're going to use the last year. But under certain conditions, suppose if the process is closer to random walk, then this transformation works a little better. It has a little better predictive power. So this was a little bit of panel VAR introduction to dynamic panel models. Now we're going to talk about the VAR models, vector autoregression models. So here we're going to have a system of equations and a system of dependent variables. This model is useful when, say, in macroeconomic models, many variables affect each other over time, and it's not clear what is dependent variable, what is independent variable, right? So say we have interest rates, we have inflation, and we have GDP growth, the three main macro variables. All of them are dependent variables, right? Because they all gonna affect each other over time. This would be sort of the most simplest macro model, right? So now we cannot say which one is dependent, which one is independent. They all gonna be, in fact, dependent variables. They're all gonna affect each other over time. So here, the y is a vector. So in this example I just gave you, the simple VAR model, you can have inflation, interest rate, and GDP growth. Okay? So the y is now going to be a vector of three variables. In essence, you're going to have three equations. And each equation is going to be a function of its own lags and other variable lags, because it's dynamic. So what happens to growth of GDP this year is going to affect inflation and interest rate next year, and vice versa. What happens with interest rates this year is going to affect growth next year, right? So that's how you get this system of interdependent variables. They all are connected. And that's why this method was created to estimate. It was created in macroeconomics in the 60s by Sims, was the first VAR model. So as before, we have now this fixed effect, because now it's a panel, right? So let's say we have these three variables that I mentioned, right? Inflation, interest rates, and GDP growth. Well, if you take one Ukraine, it's only one country, so you only get time series. You don't need panel VAR for that. You just use standard VAR method. This is a standard VAR method. But if you had, like, say, 10 different countries, and you wanted to estimate a model which will be using all the data from 10 different countries, then you'll have a panel VAR. So then you'll have the fixed effect, again, because each country is unique in ways that are unobservable, okay? And then you can put in what's known as time fixed effects for each year. Maybe something was happening in global economy, something that's commonly affected all the 10 countries. Then you will capture it by the time fixed effects. And here we'll have those three variables that we talked about, just for example, inflation, interest rate, and GDP growth. And you can have as many lags as you would like. You can have one lag, which would be 1 year back, or 2 lags, 2 years back, and so on. It depends on what you believe, how many years it takes for, you know, what happens today, how many years in the future is going to affect other things. Okay, is that pretty clear? Okay, so the VAR model here, in essence, is a dynamic panel with lagged dependent variable. So the reason I give you that introduction, because those problems of estimation, those dynamic panels, are going to apply to panel VAR estimation. Okay, so all this is going to apply to panel VAR. So how we're going to estimate it is the same way. We need to do 2 steps. First, we need to transform the equations, either first differencing or this FOD, which is forward orthogonal deviation. And then we have to instrument. We have to use untransformed variables as an instrument. We can either use IV or GMM. Small differences. If someone is interested, I can talk about that. Okay, so once we estimated the model, what we're most interested in is called orthogonal shocks. For example, in our three-variable, very simple three-variable macro model, which has interest rate, inflation, and growth, maybe you want to know how the shock to interest rates, which is something the bank can have control over, is going to affect future growth and inflation, right? So this what you might like to know is what's known as orthogonal shock. You want to keep, let's say, inflation constant, and you want to see how changes in interest rates is going to affect changes in growth. Can you imagine that? Would something be interesting to know? Okay. But the problem is that inflation is not going to stay constant, right? Because all three things are going to move at the same time. So to do this kind of exercise, you need to impose the restrictions on your model. Okay, so you need to have a theory or some sort of intuition about the order in which things going to affect each other. Okay, so when we write this model in the general sense, it's symmetric. So all three variables, interest rate, inflation, and growth, each equation looks the same, right? So we have interest rate regressed on lagged interest rate, lagged growth, and lagged inflation, and so on. All system is going to be symmetric, so it's going to look the same. But it's not going to help you with this orthogonal shock. Okay, so to do this exercise, you need to create restrictions. In the past, there are two ways to do that. One way is to do a structural model. You have to have a theoretical model which will tell you in which order things affect each other. Or you can create a reduced form which will only depend on the ordering of the variables. I'm going to explain this a little bit more because this is estimating panel VAR. This is one of the key things you need to do, okay? And it's what's known as identifying assumption. So we need to structure our model. It's also known as either Koleski decomposition or it's known as recursive ordering. And to do this, we need to create an order. Let's say we had these three variables that I've been using, right? Remember, everyone, remember what they are? Inflation, interest rate, and? Okay, very good. Just checking. So we need to create an order. We need to decide which one we're going to put first, second, and third. And that's going to matter for our identification. It's going to matter because whatever we put in the first is going to affect other variables in the same period. Let's say the same month if we have monthly data, if we're lucky, or the same quarter if we have quarterly data, or the same year. Okay? So if we said that out of those three variables, which is going to come first? Let's say we said interest rate is going to come first. And then we said maybe inflation is going to come second and growth is going to come third. If we put the order like this, it's going to put some structure on our model. Okay? It's going to constrain how the model is going to work. The way it's going to constrain it is going to say that because we put interest rate first, interest rate is going to affect inflation and growth in the same time period. But inflation and growth are going to affect interest rate with a lag of one period only. Okay? And the same with inflation. Inflation is going to affect growth in the same period, but growth affects inflation with a lag of one period. So that's the way to impose the structure. Now, where does the structure is going to come from? Ideally, you will have some model or some intuition that comes from another source. Why would you structure them that way? Okay? Many applications, you use your logic, you use your reasoning, you use all the other outside knowledge, because the program is not going to know which one is the right ordering. And as usual in econometrics, you cannot test usually what's the right ordering. It's hard to use data themselves to tell you what's the right ordering is. You have to use some kind of model, prior knowledge. Okay? So you're still going to get that all the variables are going to affect each other, but the restriction are going to be on the timing, how fast the effect will happen. Okay? So in this way, you kind of like you keep the endogeneity. All three variables are endogenous and affecting each other, but you put a little bit of structure on it. And this structure is going to allow you to get that orthogonal shock. It will allow you to know what will happen to, if one variable changes, let's say what will happen if interest change, what its effect on growth while inflation is constant. Even though in real world you cannot keep inflation constant. Once you impose such structure on your model, you can do that exercise. Any questions yet? Yes, please.
During monthly data, quarterly data, or annual data. Because you know what is the point? If you have, let's say, annual data, our restrictions are not so reliable in terms of content.
Right.
You know, interest rate probably will have the
right.
inside the year.
Right, exactly.
So what is the community?
The shorter frequency probably would be better to argue, because you need to create a plausible argument for these restrictions. If you only have annual data, you really cannot argue that it will take a whole year for the effect to manifest. It's not realistic, okay? So this assumption is something that you need to convince other people that it's realistic. And the more shorter time horizon data you have, the more easily it will be to convince people, yes, the interest rate will take maybe a month or two to manifest in the growth, and vice versa. That's an excellent question. Any other questions? Yes?
How do you identify that your order is wrong? For example, if you just put a restriction and based on the model, how do you know everything is going okay?
Yeah, it's a very, very good question. You cannot really know for sure. You have to have a plausible reason coming either from a model or from your logic and intuition.
Are there any, for example, price terms when you look at the model and you understand that even if with plausible assumptions, it is wrong? Do you understand?
You see the thing in red? It's not, okay, it doesn't say here, maybe in another one. The hard thing about this, it's not testable. You don't have a test to tell you that your assumption is correct. And very often in economics, your key assumption is not testable, right? You have to assume something that you cannot test exactly. So how good your model is will depend on this assumption, and will depend on how good your reasons are. So just in a few minutes, I'm going to start talking about specific applications. And in each case, all of 3 of my papers, I had to have some argument, right? And that argument needs to be kind of sensible. It needs to be something that people could believe in. Like in this question, if I only have annual data, nobody's going to believe that it's going to take more than a year for one variable to affect the other. So you have to have some argument to make it believable. Any other questions? Okay. Okay, this is another example that I thought of that we already mentioned. We have 2 variables here, foreign aid and growth. Okay. Very simple model, 2 variables. You can, if you think about it, obviously foreign aid will depend on past growth, right? The agencies that allocate foreign aid, I used to work for the World Bank, agencies like that, they will look at the past growth performance in decisions on foreign aid. At the same time, growth, you would hope, will also be affected by foreign aid. Okay? So, if you just had those 2 variables, how would you order them? What would you put first? In this situation, you can create a story or you create a reason that will justify both ordering. For example, if you believe that it will take some time for foreign aid to impact growth, right? If you give foreign aid this year, maybe it will take time for the effect to be manifesting in the growth rates, right? Because that aid needs to be used, it needs to be invested productively, and that takes time. So maybe your theory will suggest that foreign aid affect growth with a lag of 1 period. This will suggest putting growth first. That's one possible model. On the other side, you can say foreign aid will respond to past growth with a lag. Why? Well, the data is not immediately available. Okay, let's say when the donors decide on aid, they're making a decision in January of 2017. Maybe the December of 2016 data is not yet available. It takes time, the data reporting lag. So it will be some time before growth will affect aid because simply availability of the data. So if you think this is the situation, then you have to put foreign aid first. Okay? Now notice that these are mutually exclusive assumptions, but you can create justification for both. Okay? Maybe they're both right. So in this case, it will be hard for you to argue that if you put growth first, maybe hard for you to really prove it that this should be the case, because the alternative interpretation is also possible. So maybe this is not a good candidate for panel VAR, unless you come up with some plausible story for your ordering. Now, I had a student recently who tried it both ways, and the results are sensitive. So you get one result one way and a different result another way. Sometimes it may not matter, because nobody preventing you from running it both ways, and if results are the same, then you don't have to worry about it. You just say, okay, my results are not affected by the ordering. But very often they are. And so maybe this foreign aid debate, people are right on one side and the other side, because both scenarios are plausible. Okay, so just to summarize, this assumption is untestable. You don't really know what the right ordering is. You have to use some intuition or theory if you have one, and the results may change. Okay? So that was my kind of general introduction to panel VARs, and now I'm going to talk about specific applications. Yes, please.
If you talk about the methods for identification, so usually for the standard VARs we can use other types like long-run restrictions or, for example, sign restrictions for, yes, in addition to this just simple ordering of variables. Could we use the same approach for the panel VARs?
You can, technically you can use all the same restrictions if it's programmed, right? Now, I haven't used other ones because the programs I wrote use recursive restrictions. So all the work I have done only used this restriction. But in theory, you can use all the restrictions. You just have to program it. That's all, right? So a lot of people now use the recursive ordering because it's the simplest way. It's definitely the simplest way. Okay? But technically, all the other restrictions should be fine, right? You just need to have the right number of them, given the dimension of your system. Yes, good question. Okay, so the first paper I'm going to talk to you about this, now we're going to talk about specific applications. Okay, so financial development and dynamic investment behavior. We're going to, for this paper, we used firm level data. So different corporations around the world. And we looked at the investment into capital, which is property, plant, or equipment. So investment was our key focus. And in theory, investment should be a function of what's known as fundamental factors, which is profitability. If the business is profitable, you should be investing more into this business, right? Pretty clear intuition. So it's a marginal profitability is the key factor they should determine if the firm should be making the investment or not. However, the second set of factors is known as financial factors, which is simply a cash flow. In practical way, a firm will invest if it has money to invest, right? Now, if financial markets work well, then the firm's investment should respond to fundamental factors and not financial factors. What this means is that firms with good investment opportunities should be able to borrow money and invest. And their investment should not be a function of their own cash flow. It should only be a function of whether they have a good investment opportunity or not. That is the main function of financial markets, is to allocate capital efficiently to firms with good investment opportunities. Okay? How can we test this in the data? So we wrote this paper. This was part of my dissertation when I was at Columbia University. I have another paper that looked at the same question with a different method. We didn't do panel VAR in my first paper, but for this paper we used this panel VAR methodology. So the idea is very simple. If we have a bunch of countries, maybe 40 countries or 50 countries around the world. Some of them were developed countries, some of them were developing countries. In developed countries, the idea is that financial markets work well. So if financial markets work well, the investment should respond more to which kind of factors? Fundamental or financial? Fundamental, very good. If markets work well, ideally, that's the only thing that should matter. Of course, even the best financial market doesn't work perfectly, but the idea is that the response to fundamental factors is stronger in countries with better developed financial markets. Okay? So we did this, we wrote this paper and we split the sample. We had one sample developed countries, one sample developing countries. And we wanted to look at the relationship between basically three things. Was investment, which is investment scaled by capital. So investment we call new purchases of property, plant, and equipment, or machinery, or land, or any kind of capital. That was one variable. The cash flow is cash flow, how much cash they have that year. And here we have sales to capital, which we used as a proxy for marginal product of capital. Okay? So we also used the model with Tobin Q, which was based on the market value of the company as another proxy for marginal, for fundamental factor. So here we have investment. This is the financial factor of cash flow, and this is the fundamental factor of sales to capital. And here was our argument for the ordering. Remember I said we need to create the ordering and we need to have a convincing story of why this is so. So we put here sales to capital first. If it's measuring marginal profitability, we argue this is the most exogenous, like it's a shock to sales. It's something that could be outside of the firm's control, could depend on the demand for their products or some other outside shock. Okay, so this one came first in the model. So what this means is the sales to capital will affect cash flow and investment at the same year. We only had annual data, while investment will affect sales with a lag of 1 period. Now, in my mind, this was sensible because if you make a new investment, it's not going to produce your sales at the same time. It needs time to put a new investment into place, right? If you're putting a new building or you're buying new machinery or you're creating a new factory, it takes time for it. So that was the argument for the ordering, right? Investment only affects sales with a lag because it takes time for it to become effective. So we kind of decided that this comes first and this comes last. And cash flow, we don't have a very strong reason for it one way or another. But you know, as long as you know what has to be first, what has to be last. And investment is affected by cash flow immediately, right? Because if you have cash flow this year, you're making investment this year. But in reverse, investment will affect cash flow with a lag. Okay, so that seemed very sensible ordering. And nobody really questioned that, so it wasn't hard to argue in this case. So when you get your VAR, and one of the outputs that is most interesting to look at is known as impulse response function. So we run one log VAR and we have sales, cash flow, and investment. So the first row of graphs, it shows you the response of sales. This is to its own shock. This is the shocks of cash flow, and this is shocks to investment. And this is how you can tell where the restrictions come in. You see that this one starts at 0. So it restricted in the very first period. The cash flow is not affecting sales, right? Because of the ordering. But on the other side, the sales is going to affect cash flow in the first period, right? So these two are constrained with 0 here, 0 here, and 0 here. So this is the recursive ordering. You see the diagonal, it's their own shocks. All of these three, the three of these impulses are constrained to 0 in the first period, and the bottom ones are not constrained. So the highlighted ones is the ones that were most interesting, which is response of investment, and this is response to sales shock, and this is response to cash flow shock, and this is its own shock. Okay, and this program you can generate the 3 lines here. The middle line is your point estimate, and the 2 lines are the error bands, and we did 5% on each side, generated by Monte Carlo. Here, this paper used 1,000 repetitions, but it's all in the program. Any questions about this? Because we're going to see more of the graphs like that. So as I said, this is one of the most interesting things with panel VAR. The estimates themselves, the coefficients, are not that interesting to look because you cannot interpret them very well. This is interpretable. So what this one tells you is if there is a shock to sales to capital, for example, how much investment will respond. Okay, so this number is meaningful, and the shape of these lines is also meaningful. It tells you, well, first of all, obviously, it tells you if the response is positive or negative. In this case, you obviously want it to be positive, right? So higher sales to capital, which in this paper we call fundamental factor, means that your investment is productive, so you should be making more investment. Okay? So this is good. It makes sense, it goes in the right direction, and it's very significant. Now, this one is also significantly positive, which this one tells you if you have cash, you're going to invest more, right? You have more cash, you're going to invest more. Okay, so what we did next is we have now we split this sample. So this model in this slide is developed countries. And then we run the same thing for developing countries. And we get similar patterns. But what's most interesting is to look at the difference. How developed countries are different from developing countries. So this graph was, each of this is the difference now of undeveloped minus developed. So again, we're going to look at the bottom set of graphs. What we observe here is in undeveloped countries, the response to fundamental factors is smaller. You see now it's negative, and it's significantly negative. So investment has less response to fundamental factors, and here it has more response to financial factors. Again, this one is significantly positive. So this was the main result of that paper in this graph. Okay. Any questions about this? Okay, one other thing we can look at, which I haven't mentioned, is called variance decomposition. In a way, it shows you the cumulative response. Which factor has a larger impact? So here I'm showing you the split. First set of numbers is for low financial development sample, and this is for high financial development sample. Remember, the idea was to compare countries that are more developed with countries that are less developed. So what we observe here is the response to, this is a response of investment to cash flow shock. In low financial development, it explains 13% of variation, and in high financial development, it's 16%. Wait a minute. Row variable explained by the column variable. Right. Oh, yeah, this is wrong. This should be this column, and this should be this column. That's why. Okay? So in high financial development, the sales to capital has a larger effect. It's just putting into numbers what we saw on the graphs. Okay? So what we saw here, that in high financial developed countries, sales to capital has a larger impact on investment. In other words, it's negative here because it's undeveloped minus developed. Okay, so graphs is a visual way of seeing that, and the variance decomposition, it's kind of an R-square type of measure, which you can put numbers on this. And here we have that low financial development, larger response to cash flow shock than in high financial development. Now, the numbers here wasn't as dramatically different. I think it was more visually interesting to see the graphs rather than the numbers, because the numbers, the magnitude didn't look that much different. Okay? So this is just to summarize this paper, what was the main results, that fundamental factors have less effect on investment in countries with low financial development. In other words, firm may pass on profitable opportunities, so financial market is not working as effectively as it should be working. And on the flip side of this is financial factors have stronger effect on investment in countries with low financial development. In other words, firms will invest more when they have more cash. So meaning their access to credit is not as available as it should be. Okay, so the implication was here that financial markets do not work as efficiently in should be channeling resources to their most productive uses, which is the main function of financial market, that resources are allocated to the most productive use. Okay. Yes, please.
Maybe have you tested, or maybe you have some beliefs, assumptions? Does the gap between developed and undeveloped countries changes and varies depending on crisis or during different years?
This would be a really good paper to write. No, I didn't do that, but that's a very good question, right? You can look at if the crisis makes developing countries even worse off. That would be a really good thing to look at. I suggest, good idea. Any other? Yes?
What was the difference between, or how did you measure the level of financial development of any country?
Yeah.
Is it just that developed countries, the OECD countries, are having a high level of financial development and the rest are worse off?
Yeah, I think for this paper we used the total credit to GDP is one of the common measures, how much credit has been given in the country relative to their GDP. This data comes from the World Bank. This paper was written in maybe 2002, and since then I know the World Bank developed a lot of other measures of financial development. If any of you are interested, the data is available on the web. They have a financial development database. Now they measure many different aspects of financial development, right? They measure stability as part of it, size. So this here is just a measure of size of a financial system, but now it's more sophisticated. I think they measure size and also the efficiency and access of corporations. So that data now is available on the World Bank website. But here it was pretty basic, because at the time that's what people used in the literature. So that's what we used. Yeah, very good question. Okay, so I'm going to shift to talk about a different paper now. This was a specific country. The first paper I talked about was using firm-level data on 40 or 50 different countries. I don't remember. This is one country, and we're going to use bank-level data for this country. So maybe something that is more close to what you guys are doing. So here we investigate interaction of banking sector and macroeconomic variables. Maybe something really close to what you may want to do. In particular, my co-author on that paper was interested, she may be from Egypt. She was interested to look at how foreign capital inflows and growth affect banking sector. Okay, so the more general question is how macroeconomic shocks, and again, here we only looked at two different main shocks, foreign capital inflows and growth, are affecting banking sector. But in reverse, banking sector can also affect macroeconomic performance. Okay? So again, the VAR is well suited here because things affect each other. And I think the novelty of this paper is that we combine bank level data and macro data. So we had a panel of banks, but obviously macro data, since it's one country, it's the same data for each bank. Okay, so we had 3 macro variables and 3 bank level variables. On macro side, we used capital inflows, GDP growth, and the interest rate or lending rate. And bank level, we used loan growth, we used reserves, and we used return on assets as a measure of performance. Reserves we used as a proxy for loan quality. I think that's what the best was available in the data set. It's a bank scope. No, actually, it's Egypt. I'm not sure where the data came from. My colleague was working with this data for Egypt. Okay, so we're going to put the baseline ordering. We're going to put capital flows first because it's the most exogenous variable, right? It's coming from the outside of the country. We said that it will affect contemporaneously GDP growth and the lending rate, and then all bank variables. But all other variables impact capital account with a lag. GDP growth, we had contemporaneous effect on lending rate, and so on. Okay, and then on the bank level, we said the loan growth came first, which affects reserves, and profitability came last. Also, we put all macro variables first. We said all macro variables affect banks immediately, but banking variables affect macro with a lag. Okay? Because macro shocks are likely to be transmitted to individual banks. This is our annual data, I believe. But the individual bank performance may affect macro with a lag. Okay? Okay, so now we have 6 variables, so we have a bunch of these little graphs, and I'm going to have fun interpreting what all of the different things mean. So you cannot read any of that, but the first 3 is macro effects, how, I can't even read this, so this one is a capital account, this is GDP growth, this is lending rate, and now we have bank growth, we have reserves, and we have profitability. Okay? So again, each one is affecting each other. The diagonal, it's an own shock, and so on. So the 3 first top ones is a macro affecting macro variables. The 3 bottom ones is a bank affecting bank variables. And very interesting is this quartile, which shows how macro variables affect different bank variables, right? So the 3 graphs here, each of us, for example, how loan growth is responding to capital flows, how loan growth responding to GDP, and how loan growth responding to interest rate. Okay? And the top 3 graphs will show you how macro variables are affected by different bank performance. So basically, I'm going to summarize some results for you from this bunch of graphs. Now we're going to interpret them. So what we found is that GDP growth responds positively to capital flows, and response lasts about 1 to 3 years. So that's another thing. You can look at how long the response lasts. For example, this is the effect. This is the graph that I'm just mentioning. Response of GDP growth to capital account. So you can see that it's positive only for about 1 or 2 years, and then it becomes not significant. So you can, from the graphs, you can determine whether it's positive or negative, whether it's significant, not significant, and you can also look how long the effect lasts. Okay, so kind of all the information is contained in the graphs. Okay, so we find that lending rates will decline in response to capital account shocks. These are expected results and show positive influence of capital inflows on the Egyptian economy. We have decline in interest rate in response to positive GDP growth, but GDP growth responds negatively to positive lending rate shocks. This is your standard macroeconomics. Interest rates are not really good for GDP growth, right? You increase interest rates if you want to contract the economy. So increasing interest rates is a contractionary macroeconomic policy, will negatively affect growth and also discourage capital inflows. So those are standard results. Now this is the bank level results, how different bank variables affect each other. So we can see that reserves decline, which means that loan quality improves, in response to positive shock to profitability or loan growth, which is kind of what you would expect. Loan growth increases in response to positive shock to profitability is also something you would expect. If you're profitable, you're going to increase your loans. Profitability increases. So there was some kind of interesting response of reserves. Now, immediate response was negative, and then it changes. So we had to kind of come up with an explanation for that. We thought that taking a hit today in terms of higher reserves will imply that there will be less need for write-offs in the future. So the first response is negative. Right? If you have more reserves, then you have less profitability. Just the other day I read a paper. I'm also an editor of Journal of Banking and Finance, and the paper looked at how changing accounting standards that happened in Europe had to do with the reserves, where the bank had more or less flexibility about taking, more or less reserves, and they can manipulate income more. So they're similar. And then something we were really interested in is how macro variables affect banks. So we found the positive shock to capital account results in higher loan growth, drop in reserves, which is a good thing, which means improvement in loan quality, and also increase in profitability. So all these three things suggest that capital inflows actually improve bank performance on all three dimensions. Positive shock to GDP triggers positive loan growth, which is also something you would expect. Negative response in reserves, something you would expect. And improvement in bank profitability. Okay? And the lending rate has negative impact on profitability and higher reserves, which we interpret as a lower portfolio quality. Okay. Any questions about this? So this is maybe something closer to what you guys working here at the central bank. Okay, and lastly, I'm going to talk about one more paper. If there's no questions. Yes, please.
Is it possible to implement the same approach when you have different sets of banks, for example, for different years? I'm asking because, for example, in our case, we used to have something like 180 banks at the beginning of 2014, and now there are less than 100 here. So.
Yeah, you can. You don't have to have a balanced panel. You can have different banks. Now, if there were some bank mergers, things like that, then you need to be careful with that. So I think what they do, if there are two banks merged, so you had two banks in 1 year and then one bank in the next year, then you have to kind of go back and aggregate those two banks to make it consistent, right? But technically, you don't have to have a balanced panel. You can do that with any number, just being careful about mergers.